All right, in part one of today's third quarter common assessment review, we're going to go over the first 7 questions. So in the first few questions, it deals with function, not a function. Whenever you're given a graph to test if it's a function or not a function, you have to do the vertical line test. So vertical line test is up and down. So if I go through option A, I can see here that if I go here, that it crosses more than once there. So if it goes through the graph more than once, it's not a function when you make a vertical line. So that's why it's the vertical line test. So for part B, example B, here in this vertical line, it goes through 3 times, so it's not a function. C, it goes through 2 times. And in D, that's the only one that no matter where I make my vertical line, it only goes through once. So the correct answer is D, is the only graph that shows a functional relationship. So the answer to number 1 was D. Number 2, when it came to coordinates or tables, we learned that in order for a table to represent a function, the x cannot repeat or double. So I'm looking at all these values when I make my decision if it's a function or not. So basically, as I look through here, the only one that here in A, the -1s repeat. In D, the -2s repeat. And C, it looks like the zeros repeat. But in B, 0, 1, 2, 3, 5, nothing repeats. So therefore, B is your only function. In example C, again, the x cannot repeat. Sorry, not example 3, number 3. So I'm looking at the coordinates and seeing if any of my x's don't repeat to make it a function. So here, -2, 0, 1, 2. So I guess I got lucky there because none of those -2, 0, 1, or 2 repeat. So that must be a function. Just to show you an example A, it looks like the -2s repeat for x's. In choice C, 4s repeat multiple times. And in choice D, the 10s repeat. So the answer to number 3 is B. Turning the page to number 4. It says Mike leans on a 10-foot ladder against a wall. He puts the bottom of the ladder 3 feet away from the wall as shown. So we want to find this part right here, approximately how far up the wall does the ladder go. So this would be a job for the Pythagorean Theorem. So you have to label your sides. A squared plus b squared equals c squared. So c is always the longest side. That's your hypotenuse. And it doesn't matter here. I'll just call this A and this one B. So when I plug in my Pythagorean theorem, I get 3 squared plus b squared, which I don't know. So I write just b squared equals c squared, which is 10 squared. So when I get this, I get 9 plus b squared equals 100, and minus 9 on both sides. I'm left with b squared equals 91. And the last part here is to square root both sides, and I get the answer of b equal to 9.5, which is B. So it is 9.5 feet up the wall. Same thing or similarly in example 5, you're looking for the length of this rope. So again, using the Pythagorean theorem, we now know that we're using the a squared plus b squared equals c squared. So we'll label our sides again here. This is C, so the longest side opposite the 90-degree angle, and call this A and B. So when I plug this in here, I simply get 10 squared plus 24 squared equals c squared. This gives me 100 plus 576 equals c squared. That's 676 equals c squared. Square root both sides, and you get c equals 26. So the length of that rope is 26 feet. 2 more questions here. We'll skip 6 for last, but looking at number 7, Paul says the triangle with the side lengths 8, 14, and 17 meters is a triangle. As a right triangle, it has to say a right triangle. So now you need to decide, is that true or false? So you use the Pythagorean Theorem. The longest side is your C, and this can be A and B. And you just test it. So you decide, does 8 squared plus 14 squared equals 17 squared? When you do that in your calculator, you end up getting, I'm just going to move it over here to the side, 64 plus 196 should equal 289. That's just doing 8 times 8, 14 times 14, 17 times 17. Turns out that that is 260 equals 289. That is not true, so therefore that statement that Paul made was false. And last but not least, you have a box, and Olivia's box holding the baton just perfectly on the diagonal. We learned earlier in our lessons that instead of doing the Pythagorean theorem twice and finding a hypotenuse right there, and then using that answer to find a hypotenuse here, we could just do the length, width, and height squared, add them all up, and then that should equal diagonal squared, and we square root. Trick here is that this 1 foot, you need to make sure that's 12 inches. So when you plug in your numbers, 9 squared plus 12 inches squared plus 8 inches squared equals diagonal squared. This comes out to 81 plus 144 plus 64 equals d squared. And that comes out to 289 in my calculator equals d squared. So that means you actually get what we had in Paul's example, what we should have had, which was d equals 17. So this is the first part, so the diagonal equals 17 inches of that baton. So this is the first part of the review for the third quarter assessment. Stay tuned for part 2, where we'll be looking at volume and rational, irrational numbers.